Alright, so then let's start the class. Yeah, Anshu. So this is the entire set of kids we have in the class. On screen we have Srivatsav, Dev, Prisha, Sarah, Sravya, Rehan, Neil and Anshu. And then in the classroom we have Praneeth. So, did anybody get a chance to see what all we are going to learn today? Any idea? No idea? Okay. So basically now, as I would have probably told you guys before, today's class and this weekend's class, meaning today, tomorrow and the next Saturday. These three classes we are doing for randomly picking up some topics. But then from February the 1st, we will start from beginning of the SAT syllabus. So basically, we start from Unit 1 in Khan Academy and go all the way till Unit 12 or 13. What we will do probably is, we'll not try going into each and every detail because a lot of things would be known to you guys. So what we'll do is, pick up a topic, look at all the concepts, do a quick check what we know, what versus what we don't, and then focus more on the thing that needs more emphasis, right? Just as an example, the first unit is about number system. It would not be fair or productive for us as a team if we talk about the prime numbers or natural numbers or whole number or fractions and whatnot. So we just quickly skim through those concepts just to make sure that nobody has forgotten those concepts, and then focus more on the things that would be of interest for us to delve deeper into things and practice it more for being better prepared for our SAT exam. Does it really make sense to everybody? Okay. Alright. So today's topic is data and statistics. So now a question to you all. What do we mean by data? And what exactly are we referring to when we talk about statistics? And how does it actually help practically? Any starting thoughts? See, I'm not only trying to teach you guys math, but my goal is to make sure that you guys are able to articulate what you learn as a concept and how that relates to a practical thing in our day-to-day stuff. Yeah, then. So.
Hi, sir.
So we are just starting the class. So today's topic is data and statistics. So what I'm trying to understand from you guys is, what do we mean by data? And what is statistics and what is its relevance? Any starting thoughts that you guys want to share? And don't be shy, it's okay. You're just sharing your point of view. There's nothing right or wrong. Yep.
Data is real world examples where we can pull information with numbers like sales or number of lemonade sold for this many dollars. We sold 20 lemonade today, stuff like that.
Okay. So what Praneeth is saying, data is like a set of information based on certain criteria. It could be sales data, it could be any other kind of data in numbers that we come across, and then probably look at what is the meaning of that. And data is in simple form. It's nothing but a piece of information represented in form of a number mapping to a unit. Let's say if I say $20, it's a data. If I say 50 cents, that's a data. So it has two elements to it. One is a number and then the unit, right? If I say 50 and stop there, that doesn't give me the right view of what exactly I'm talking about. Am I talking about $50? Am I talking about 50 grands? Am I talking about 50 millions? Am I talking about 50 cents? Right? Am I talking about 50 rupees? Right? So data is a piece of information, is a unique piece of information that tells about its magnitude and the unit. That's what I would say. So now data could be anything. It is not necessarily always numbers. Data could be the area of this classroom. Data could be number of kids in the class. Data could be how many hours you are spending for studies. Data could be how much you score in the city, right? Data could be how much marks you have got in each and every subject in your exam. Data could be how many teachers you have in your school. Any information that is self-sufficient to describe itself. If I just pick a number and say 20, it doesn't go anywhere. It doesn't hold any meaning to anybody. But when I say 20 teachers, then it gives some clue that okay, we're talking about 20 teachers, be it a teacher in a school, be it a teacher for a particular subject, be it a teacher for the entire school district, be it a teacher whom the kids don't like. I could be one of them, right? So what I'm trying to say is data is a piece of information which gives you some clue about the information that you are trying to talk through. Yeah. Now, if I say, or sometimes data may not have unit. If I just say 5, it's a number. It could be 5 students, it could be $5, it could be 5 houses, it could be 5 agents, it could be 5 airlines, it could be 5 cars. It is still say, okay, there's a number 5 that we're talking about. Now, so let's start with the number. If I give what do you see on the board? Set of data, certain numbers, might be something, might be people's age, might be the number of hours every kid is. Maybe every kid's number of hours spent for studying a subject. Yeah. But what you see is these are just random data. It's not giving any clue. This form of data is called unstructured data. You have data, you have information, but there is no head or tail that you can derive out of it. There is no conclusion that you can draw from the information that you have. Or even if you can draw, it will take a lot of effort because this is in a very unstructured form. There is no pattern. I started with 2, went to 8, came down to 5, then again went to 8, came down to 7, then 9, 16. If I say, okay, I have this information, what will be the next number? Nobody can guess. I mean, you can guess, but how accurate that guess is, you will not be confident. A moment of silence. Are you guys with me? Okay. Oh. So I'm just trying to check and reaffirm that whatever non-stop talking I'm doing right now, is it able to digest? Is it digestible? Okay? Is it something that is making some sense? So far, if you look at, or if you recall what we have discussed is, we just talked about what is data. Data is nothing but information, which may or may not have two parts to it. One is the number, one is the unit, right? And then we are talking about, okay, just data is information, but how important it is to have that information in some shape and form which helps you derive some conclusion out of it, which helps you interpret. Now look at this number and then you look at this. So this is one set of data and this is second set of data. What is the difference between this set and this set? Yep.
The second set has like a certain value it's increasing by, so it's you can guess the next number.
It's a more predictable pattern that you see here, right? It's a little bit more structured, it's more organized, it's more conclusive in nature. Yeah? Are you guys with me? Sarah, Neil, Anshu, everybody? Yeah. Okay. And I'm just calling out some names randomly, okay? It doesn't mean anything. So, data is a piece of information. Now, when it comes to data can be in two forms. One is called unstructured form like this, which doesn't give you any conclusion. It just gives you information, but no conclusive view that you can derive out of it. And the second form is called structured form. where you can predict if I have, let's say, certain information, what would be the next information. Or just by looking at this data, you can see that, okay, fine. Every number is a difference of 3. And if you look at all these numbers, if I have to find out the average of this number, you'll say, yeah, average would be somewhere between this, in the middle, because it's an increasing order, right? So it will be somewhere here. So that's the difference, that's the main difference between structured and unstructured data. Unstructured data is just a piece of information without having the ability to give you any conclusive view. And unstructured data is what I was talking about. And when you talk about structured data is a set of data, set of information given to us, which is little more organized, little more predictable, and it helps you derive some conclusive view out of it. Is that a good starting point? Rehan, Prisha, Shravya, see what's up? Does the silence mean yes or no? Means yes. Okay. So when you now we will kind of go a little deeper into the difference between structured and unstructured data, and then we will find out different tools and techniques that we use for being able to use the data in a more efficient way. Okay. So now, since we know what is the difference between structured and unstructured data, let's see who plays what role to make unstructured data as structured data. If I give you guys a set of data saying, okay, 60, 45, 80, 92, 89, 77, 54, 99, 3 plus 3, 6 plus 2, 8, 100 and 36. I'm saying that this is the information about the score of 10 students in a particular test. Out of 100, these are the marks scored by 10 different students. Okay? It is still unstructured, but at least we have the information that it is nothing but the numbers scored by 10 different students in a test which was for 100 marks. Are you guys with me? Okay. Now, with this information, I can look at this information like this, and then, okay, I can make some meaning out of it. That's okay. Now, every time I look at this set of 10 data, I understand something, and when again I come back to this, I might miss something, might interpret something, I might conclude something, but there's a lot of hard work that I have to do. Memorizing 10 numbers, right? I mean, you guys study in school where you have hundreds of kids in the same class. Imagine if this is the data for 100, I mean, if you have data for 100 kids written in the same form, how interesting that exercise would be, right? Now, look at this. With this information, I will say fine. Now, let's say, I'll say marks range and number of kids. And I'll do a little boring exercise right now, but that will probably help you connect the dots better. Now, what I'm saying is, let's say 0 to 40. How many kids? 40 to 60, how many kids? 60, so it will say 41 to 60, 61 to 80, 81 to 100. Now what I'm doing is, I'm trying to group the marks scored by kids in these ranges and trying to get a better view of the data. So 0 to 40, how many kids we had? 0 to 40, there was only one lucky child who got 36. So I'll say 1. 41 to 60.
3.
1, 2, 3. Yeah? So 3. 61 to 80. 61 to 80.
2.
1, 2. Right? 2. 81 to 100. 1, 2, 3, 4. 4 plus 3, 7 plus 2, 9 plus 1, 10. Now, look at this data versus this data. What you see here is, from this information, whatever data we have in an unstructured form, we tried putting some structure to it. This is called frequency table. Right? For any range or any number, how many kids have got that? So this is called frequency table. It could be for a range, it could be for absolute value, depending on what kind of data you're dealing with. So it tells you for this range what is the frequency, for this range what is the frequency, for this range what is the frequency. Now if you look at this, just by looking at this table, first of all it's very easy to read. From this I can make out that okay, out of 10 kids, 40% of the kids have got more than 80%. There was one child who probably did not study well, or who was probably very weak in the concepts. So teacher would know whom to focus on. And then there are around 5 kids from 41 to 80, which is like somewhat acceptable. Okay, I mean, sky will not fall apart, but they certainly need more attention, more focus. They have to study hard. But this is my average range, where 50% of the kids are doing just okay. 50% kids are doing just okay. This is the set of kids who are doing pretty good. I mean, again, definition of good is different, right? I mean, you guys deal with much higher percentages. When we used to study, if somebody gets 60% or more, we will have a big celebration at home. Now that is not the case. So what I'm saying here is, 40% of the kids are doing okay. 50% of the kids in the class are just doing average or a little below average. This is a matter of concern. So just by looking at this data, you are able to derive a lot of interpretation from this, right? That's one key advantage of structured data. I know I took a lot of time to kind of do this very dirty exercise, but it's very important for us to understand why do we really need to waste our time and energy understanding or learning statistics, right? This is the reason. When you have this information in a very, very random form, ad hoc form, unstructured form, that doesn't give you any conclusive view. Think of a CEO who is dealing with 5,000 people in his company. If he gets performance report of 5,000 employees in some form, how interesting that exercise would be, and would the CEO have that much time to go through each and every information to derive interpretation? He or she would like to rather look at the trend or something which is more conclusive in nature to derive an interpretation and then take the action, which will impact majority of the people in a more positive way. This is the lay of the land. This is the starting point. This is the most important understanding we all need to have. If any of you are wanting to go into the field of statistics, you have to understand that this is a very, very vast area. There are a lot of things that you need to do. There are a lot of things that you need to learn, and you will end up learning different forms of data, different tools that will help you do your job better. But then this is the starting point, which says, why do you need that subject in the first place? Am I making sense so far? Okay. See, so again, I'm not trying to put Anshu and Prisha on the spot, but one thing I'm observing is, whenever I'm asking a question, they are the first to respond and give a thumbs up, so that it conveys two messages. One is that yes, they are paying attention and they are immediately responding to my points. And the second thing is, they are also probably little afraid of me saying, oh, this old man will call out my name. So before it happens, let me put my defense. I mean, any which way, it's perfectly fine, right? So net, I certainly need everybody's attention, and more you react, more you respond, more questions you ask, that gives you more confidence. Okay. So coming back to this one. So now we know why we need statistics. What is the reason for even spending 1 minute on the subject? Yeah. Now What we did, we took our unstructured data, put that in some form, which we call as frequency table. Now, there's one more thing that you will see. Now, everybody, nowadays, do you guys read a lot of content, or you try looking for pictures, which is more intuitive in nature, right? Even if you look at your mobile, you will see there are a lot of information coming in the form of some chart, some graph, which is much more eye friendly, I would say, and easy to read. Let's see one example of that. So this 0 to 40 that I put in the table, you still have to do some amount of reading. What I can do is, I will say 0 to 40. Let's say this is my coordinate plane, this is x-axis, along which I will say the marks range. This is 0 to 40, and 41 to 60, and then 61 to 80, and 81 to 100. So this range is 81 to 100. Now 0 to 40, we had, let's say this is 1, this is 2, this is 3, this is 4, this is 5. 0 to 40, we had only one child, a fortunate one like me, who did not study well. Okay. Now 41 to 60, there were 3 kids. So till 3. Yeah. Now 61 to 80, 2 kids. Yeah. And then say 81 to 100, 4 kids. Let's say this is also below. Yeah. So what you are seeing here, or what you are observing here, is that now you don't really have to deal with the data in a raw form. You are getting a much more pictorial representation of the same information, which goes. I mean, unfortunately, my color selection is not very eye catchy, but people like you all, who are much more creative than me, you can make it look much more funkier, much more attractive, much more bright, much more eye-catchy, much more appealing, right? And this will look like fun. This will not look like study. This whole thing is called histogram. When you have unstructured data, you put that in some structure, and then you use that information to make it more intuitive, more appealing to eyes, more creative, more beautiful, right? This diagram is called histogram. So this is one of the tools that we use in statistics, and we'll keep coming across more of them. So this is just a starting point. Now I'm just curious to know who all was aware of this tool before, and who all is hearing about it for the first time. And there's no shy, nothing to be shy. I can learn at the age of 55 as well.
I knew about this tool before.
Okay, good. Yeah, and I think most of you would have probably come across this in the middle school itself, like 6th, 7th grade. That's when your journey with statistics starts, and these are some of the starting points. But again, maybe I was trying to teach that in more layman's terms, more relatable terms. So maybe it might have painted a little different picture, but concept remains the same. Are you all good? Okay. See, Anshu and Tisha were the first ones. Okay. All right. No direct attack on anybody. I'm just calling out names, and sometimes I crack poor jokes called dad jokes to keep you guys awake. All right. So this is the first one, that is called histogram. Likewise, let's see. Okay, before I do another lengthy exercise, who all knows what is a dot plot? Okay, dot plot or scatter plot, and who can give me a quick rundown of what exactly it is, conceptually, I mean, in as simple a term as possible. Yeah.
It's like using a coordinate plane and putting dots where, like, to represent data or not necessarily a coordinate plane, but just like dots wherever your data points match.
Okay, which again represents a certain frequency of a particular occurrence. Yeah. Okay. Any other point of view about dot plots or scatter plots? Think about it, accumulate your courage, and let me know when you're ready to give me a story. You guys have to be a little more talkative, okay? That is when I will not say we will become good friends, but at least the bond between the teacher and student will get stronger. Yeah.
They're easier to use to find trends.
Mm-hmm. Yeah. So what Pranit is saying is dot plots and scatter plots are the tools, other two set of tools which is used for defining trends or representing trends. Just 1 second. In the class, ma'am. Yeah, class is going on. Yeah. In person. Yeah. So, alright, so what I'm saying is dot plots and scatter plots are other two tools that we use in statistics for defining frequency or defining or deriving trend from the data. Okay, so let's look at one scenario. Let's say in a class we have, let's say, 20 kids. Okay, and again this is the most relatable thing for me because I'm talking to the kids. 20 kids, and kids are of, and let's say there are 3 subjects. Okay, science, maths, and let's say social studies. And we asked every child to select their favorite subject, one subject among the 3. So this is what we got. S for science, SS for social studies, and for math. So when we ask the kids to give that information, we noted it down. We got the information like SSC, M, SC, M, S, SC, M. Let's say 3 plus 3 is 6, 9, 12, 13, M, S, SC, 8, 11, 14, 17, and then M, SC. This is what we got. Now, again, this information is good. S stands for science, being the favorite subject for one student. SC stands for social studies, being SC, yeah. So it should have been SS, but that's fine. SS stands for social studies, being the favorite subject for any student. And then M is maths. Good information, not very intuitive. We can use another tool called scatter plot. Interestingly, in scatter plot, though you see it like a coordinate plane, but this side is only for representing the magnitude of information. Okay, I mean the value of information. This is this side you use for, this axis you use for the selection of things that you want to represent here. So let's say this is for M, this is for science, and this is for SS, social studies. Every number you got, S, that is science, 1 dot. SS, put another dot. M, one dot, another M, one dot, SS, another dot, M, S, SS, M, S, M, SS. 3 plus 3, 6 plus 1, 7, 6, 13 and 7. So just by looking at this, this is called scatter plot, where you are scattering your, sorry, my bad, not scatter plot, this is called dot plot, where every dot is representing one information, okay, and then depending on how tall is your, the dots, that tells you, okay, fine, math and social studies is most liked among the students that we picked up, or number of students liking math or social studies as their favorite subject is the same. So this is another representation, which is where you are using dot for representing every occurrence of information. It's called dot plot. So this is another tool. So be it histogram, be it dot plot, and then we'll learn about bar chart, pie chart, etc. And these are different tools that you use in statistics. So now if you relate that with what we have discussed so far, statistics revolves around data, but statistics is a tool which enriches your data for a better representation, to be able to make some interpretable meaning out of it, or to interpret something from the representation of the data to make a decision, right? So if let's say if a case was that all these dots were here in math, like a lot of students were liking math, so just by looking at this dot plot you could make out that yes, math is the most favorite subject among the kids, and just by counting the dots you would know that, okay, fine, this is the most favorite subject among the kids that we did sampling for. So all that are relating to the same point, that statistics helps you represent data, unstructured data in a form, so that you can derive interpretation from it in a much quicker and much easier way, in a much more intuitive way, and that enables you to take decisions for whatever your intents are, right? Let's say if this was the salary of people, then we'll say, okay, fine, lot of people, if this was the high salary, you'll say, oh, lot of people are getting much higher salary. So the HR will say, oh, we have to reduce the salary then, because this is where the maximum cost is going. Let's say if a lot of people, if this was high salary and this was low salary, okay, and if this plot was longer, and tomorrow if HR team in a company says or sees that a lot of people are leaving and going, when they look at this data and say, oh, this is because 60% of my population is underpaid or getting less salary, that is why people are jumping jobs. If we increase the salary, will this plot change? So when this data is represented in an intuitive form, think of a company like, pick up any service company. I mean, I myself worked in Infosys for 24 years. So in a company like Infosys where you have 300,000 people, can you go through each and every person's salary one by one to make a decision? No, impossible. HR team will plot something like this for every role, for every job band, and say, okay, fine, this is where we see the problem, by analyzing the data, and then they take decisions. Is it making sense so far? See, answer again. Okay, no, don't get me wrong, Anshu. You are always the first one, which makes me believe you and Prisha, all of you who are kind of responding quickly, gives me that confidence that, okay, at least I am effectively able to convey what I am trying to convey to some of you. Alright, so this is so we'll probably with this understanding of understanding what is histogram, what is a dot plot, we'll go on to look at some more tools which gives us more detailed view of the data, and then we will figure out how that fits in the whole scheme of things. Now, there's one more thing that you might want to look at. Let's say if we have information like this, and somebody says, find out the center of data, meaning where you have maximum concentration, where you had majority of the population being covered from the information. Then you can say, oh, this is my center of the data, right? This is where you have maximum concentration. So when we will talk about scatter plots, that is when there will be another tool that will tell us where exactly is the core of the information, where you have maximum occurrence of certain information which gives you a view to actionize on things. Okay, so we'll come to that. But before we go there, now there are things like mean, median, and mode, which is more of a mathematical tool that we use for getting some more more intense view of the data. So can somebody teach me what is mean, what is median, and what is mode? I need to be taught at this age, right? You guys have to keep on teaching me also so that I become a better teacher. So who's going to explain me what is mean, what is median, what is mode conceptually, and then what is the relevance of it? Why do you need to even learn how to use it? I'll come to you, Pranit. Let me see if I get an answer from somebody on the screen also. Who's going to teach me what is mean, median, mode conceptually, and what is the relevance of that? Why do we even need to worry about it? Sivotsav, Shravya, Rehan, Prisha, Chris, anybody? Yes, Prisha.
Mean is just the average, like a particular number of numbers in the data set.
Okay. And what is median?
Median is like the middle number of the data set.
Okay.
Or like the middle value.
Okay. Middle value of a data set when the data elements are organized in a certain way, correct?
Yeah.
Okay.
From least to greatest.
Right. Or vice versa is also fine. I mean, as long as they are they are following a pattern, right? How about mode?
It's the most occurring number.
Okay. Now, Pranit, you tell me, mean, median, mode, I think everybody knows how to calculate. But tell me the practical relevance of that. Why do you need to do that?
For mode, it gives you a trend. Let's say certain sales on certain days, it can tell you, okay, this is selling more on these days, so we should up our stocks on these days, lower our stocks on this one for this day, up our stocks on another one. And then for mean, it gives you an average. So like test scores, it gives you where most students are part, so you can see where, okay, so most of our students are not doing well, doing well average. And then median, I don't really know median.
Okay. So, if you look at mean, median, mode, okay, so let me just quickly pick up our sample data and derive mean, median, mode for them, and then we will try looking at it more like a story. How these three things are complementing each other for us to get that statistical view. Okay. Now, let's say I have price of vegetables per pound. Okay, some random vegetables. I would not want to worry about that. 6, 4, 3, 8, 2, 9, 5. Okay. So I have put the per pound price of 7 vegetables. Now, when you guys said mean is nothing but the average. So I have to add them all together. And find out the average. So 5 plus 6, 11 plus 4, 15 plus 3, 18 plus 8, 26 plus 2, 28 plus 9, 37. Divided by how many numbers? 3 plus 3 plus 1, 7. So this is 7 5 is 35, 2, 7, almost like 7.3, okay? So 5.3. Let's say it was all in dollars. So mean tells us that average price of the vegetables per pound is 5.3, more or less. Yeah, this is the mean, average. Everybody with me, right? I have just taken the average, nothing else. We have just got mean and average are two terms that you can use interchangeably. Now, what is the median? So median, for doing the median, what you have to do is you have to arrange them in increasing or decreasing order, like what Prisa was saying. Right? So what we will do is, okay, let's put that in increasing order. 2, 3, 2 is done, 3 is done, 4, done, 5, done, 6. This is also done. Then 8 and then 9. 3 plus 3 plus 1, 7. Median says arrange them in the increasing or decreasing order and find out the middle value. Now we have 3 here, 3 here. This is my middle value. 5 is the median of this is equal to 5. So now you look at this and look at this. What you see from this is that when you have, this is absolute average, this is an indicative average. When you arrange them in certain order, unless you have a very unique combination, your median and your mean, you will find them very close to each other. Here in this case you are calculating it. Here it just says, okay, arrange them and find out the one which is in the middle. Let's say you had, instead of 7, you had 8 numbers. Then you would have had 7 also here. Then this was not the mean. What is the mean is, you look at, here you have 4 numbers, here you have 4 numbers. So you will keep the 2 in the middle, so that you have equal number of numbers on both the sides. And take these two and find out the average of this. 5.5. That will be your mean, which will not be exactly the one of the numbers, but that will be the derived mean in this case. Okay. So this is more of a way to find out which number fits in the middle among the data set that you are dealing with. This one just tells you the exact average of all the values you have. 90% of scenarios, unless your data is very erratic in nature, your median and your mean will not be far apart. They will be almost similar. So there are two different ways to find out what is the average that you are looking at. Make sense? Yeah? No? Okay. Now, what is the mode? In this case, we found the mean, we found the median. Can we find the mode? Pradeep is saying that we cannot find the mode. I want to know why, and that answer I don't want from Pranit, one of you. On the screen. From this set of 8 numbers that we have, can we find out the, yes, pressure?
We can't because none of the numbers are repeating themselves.
None of the numbers are repeating. So here, this is another thing, okay? Let's say if I had something like 1, 4, 4, 8, 3, 6, okay? If you look at this number, this set of numbers, which number is occurring the most? This one. So this turns out to be a mode. Now you will say, why to even agree to this? Now, if you look at all these numbers, right? Add them together, find out the mean. 8 plus 3, 11 plus 6, 17, 21, 25, 26. 26 divided by 3 plus 3, 6. What do you get? 4.33. See, that is also closer to your mode. Your mode and mean are not very far. Your median, mean and median also not very far. So these are three different tools or techniques that the statistician, how do you pronounce it? Statistician. Forget about it. My tongue will not support me. So people who are masters of statistics, maybe that's a better term, they devise these three tools to find out the average trend. See, now if you look at this one, this average tells you, okay, if this is the number of dollars that you are spending every day for different vegetables, on average you spend $5 per pound of vegetable. Now, whether you are picking up potato or you are picking up eggplant or okra, more or less you can say that, okay, as long as I am keeping my budget this much, I will be able to buy 1 pound of one of the vegetables, right? You have multiple options. You can probably pick this one, this one, this one, this one, and you will be able to get 1 pound of vegetable, right? So this gives you an average view. Similarly, median says that, okay, if you have this thing, your median came out to be 5 or 5.5. Same thing, right? This also tells you that, okay, if you are keeping this much, this is something which is falling in the middle of all the numbers that you're dealing with. So as long as you keep that much money, you have a fair idea that, okay, this is something which is giving you an accumulated average of the data that you're looking at. Similarly, mode, see, why mode was brought into picture was, let's say if you're dealing with a data where one number is occurring so many times, that means this guy will have maximum influence on finding the average. And that we actually saw it first time, right? We had one number as small as 1 and one number as big as this, but just because this guy was occurring so many times, this guy influenced the average to be this. So when you're looking at a mode, that is the most influential number in your set of data that you're dealing with. Okay? Because that guy will dictate what your average is going to be. Okay? If you're dealing with, let's say, 1, 8, 99, 4, 4, 4. Your mode is 4. Let's say one more. You will see that this guy influences the average the most. This is the most occurring data in the set that you're dealing with. This can influence what your outcome would be when it comes to finding out the average. That's the reason mode was another technique used. Say, okay, fine. If I look at data and I see one number occurring so many times, I don't want to waste my energy and time to find out the average or median. I'll go with that. That was more of a practical approach towards making a quick decision. So mean, median and mode is nothing but 3 mathematical tools provided by statistics for getting a trend or an average view of the data that we are looking at. Moment of silence again. Any questions? No questions. So now since you guys are not asking questions, let me ask a question. Now tell me, whatever we have only 9 more minutes, so I'll probably not pick up a new topic, but just want to understand from you guys, was it the same way we looked at, or you guys looked at mean, median, mode before, or you got a different perspective now? And you can be honest, I mean, it's fine. I mean, I'm not trying to claim or ascertain that I'm the best teacher. I'm just trying to understand. Whatever we discussed just now, is that something that has brought in a different perspective for you guys, or this was pretty much in line with what you had thought before? Rehan?
I feel like
Yep.
I've never like actually gone over it in school. I don't know if it's just because like I skipped the year where like you talk about it, but for me this is like my first time actually like talking about it. I guess.
Oh, okay.
Before that, I feel like I just knew the definition. I feel like maybe this is like more like my first time actually like going in depth about it. But yeah.
Yeah. So I'll tell you guys, okay. So when you look at statistics is one of the easiest topic in the entire syllabus of maths. You will not find something that will come back haunting you. Okay, these are very easy ones. I mean, at least at this this age. Maybe once you guys go neck deep into the world of statistics, there'll be more much more interesting stuff. Some of the things might look a little tricky to begin with, but it is all about how you interpret things, how you read things, how do you make a conclusive view out of it. That is the reason you guys must be knowing that there's a lot of discussion around data science. How do you read the data? How do you do slicing and dicing of data to get some meaningful outcome from it? There's a whole industry, whole IT industry is revolving around things called data science. I mean, in today's world, it is one of the highest paid job. If somebody says that no, I have done masters in data science, he's like a king for the recruiting team, because with so many years in IT, everybody knows how to build applications, how to do different things, different functionalities and all. Now every organization has a lot of data, a lot of transaction data, sales data, employee data, health data, whatnot. How do you use the data, ingest the data? How do you derive interpretation from the data, and how do you use that for a business need? That is what is driving the change nowadays. So when you guys explore more about it, when you do more Google on data science and all, you will see that this is a hot topic. This is a hot area where there's a lot of demand for people to come back with this kind of skill. I'm not saying that what we have learned is enough. This is just we have just touched the tip of the iceberg. But this is the foundation stone for us to understand that statistics is not just a subject. I'm not trying to enthuse you guys to go into data science. I'm saying that there's a lot happening in this field. So that's why just knowing data, just doing some calculation would not be the way to go. It has to be how do we read the data, how do we interpret it, and how do we kind of massage it to get some meaning out of it. Okay. So that with that being said, I will go on pause here. And any questions? Oh, see, it's okay. Any questions that you guys have?